So now we're going to turn to how we make sure that we're keeping track of the things we're producing and how we make sure that when we make mistakes, we can back up a bit. Some of you may have worked with various kinds of versioning, either in software projects or in other kinds of writing projects. For example, if you're just writing on your own, you may save a copy of a Microsoft Word document that's final version, and then final version with Bob's edits, and then final version, no, really, this is it, and final version, this is the one to submit kinds of versioning. So you have multiple copies of the same document. But in order to make sure that you don't make mistakes or you don't want someone else to mess up what you've already done so that you can kind of see this over time, you might actually save various versions or various copies of the same document. Of course, Microsoft Word and Google Docs and other word processing software often now has its own versioning system where you can go back and see earlier edits. But maybe you don't trust that. Maybe you need to kind of do separate copies of it. Maybe you've even done what I've ended up doing, which is working on, say, a Word document that's being shared on a Dropbox where you have 4 people and you say, okay, I'm going to do these edits and then I'll let you know you can do the next set of edits. Send me an email when you're done with it and then I'll take it on, kind of a thing. Again, almost inevitably someone's going to be working on this after someone else has already made changes, and you'll have to figure out which of these changes are correct and whether we were working on the same document or what kind of a mess has been caused. This can become even more pronounced with software, where you have a software project where there's maybe thousands of files that you're all working on that may affect one another. And so the 4 of you or the 400 of you need some kind of system to keep track of this. These are versioning control systems. And so Git is now, I would say, probably the most popular of these systems, in part because it's used so widely in open source and by so many people. And Git differs from some of the earlier versions of version control where you just saved the difference between each version. So it doesn't save kind of the delta. It saves a snapshot of the entire project. So you can go back to that snapshot as it looked at that time at any one time. So that's one way that it is different than some of the other projects. The other is that it is not centralized, it's distributed. So I gave that example of us keeping a single document in Dropbox and then all of us trying to edit it at the same time. Instead of doing that, the entirety of the project is copied in various places, and then when you make a change, those changes are shipped back up to the central repository. And that way there's some significant advantages to that, in that if that central repository somehow gets corrupted or the server goes down or whatever, you still not only have your own repository of this, you probably have many repositories of it. So the process is, as you can see in the picture, you might, when you decide you're going to spend 2 hours working on this, you might do a pull where you pull down all the files, you make your edits, you explain what you've done, and then you upload those back up to the central repository. That process can happen in a bunch of different ways, and we're going to talk about using a system that allows for that to happen called Git. There's another advantage to that, by the way, which is that you can kind of maintain a central piece of software while people work on various features. So we aren't going to do so much on this for this short introduction. But as you get more familiar with Git, you'll see that people are able to fork the original project and kind of create new branches. And that main branch kind of keeps on keeping on. You can kind of get a copy of what the main version of it looks like at any time. And as people work on trying to figure out how to add a new feature, they might work on this for a while, and then eventually, when they're happy with it, they'll request that it be merged back into that main branch, and kind of become part of the newest release of that software, right? And so you have a bunch of ways you can kind of look for issues and work through those issues collaboratively, and then merge them back into the larger project in a way that may work more effectively than if you were just kind of trying to do this randomly. So it provides that kind of process for controlling people working both separately and together. Where do we do this? Well, there's both questions of how you run Git locally on your own machine, and you don't need a central repository to run Git. You could do this on your own machine, and you just get the advantages of the versioning, of making sure you can back up to earlier snapshots of the work you've done. So you can just run it locally. And when you run it locally, you can do it in a bunch of different ways. You can do it at the command line, and you can do it with there are now various GUIs, various kind of visual ways, pieces of applications, clients that you can use to interact with this. And then finally, there's some IDEs and editors that allow you to save directly from it. I'm only bringing this up because we've been using Google Colab, but if you see here, you can save a copy of this to GitHub, and instead of saving it to Google Drive, you can put it right into GitHub. This is a kind of an anomalous case because it's a little trickier than you would normally. Well, a little. It's unusual, right? So, but if you're working with a number of editors that are designed for code, they have plugins, or they natively can kind of support making changes to a file, making sure that those get registered, committed to your record of changes over time. So what are we going to do with it? Well, we're going to start with GitHub because GitHub is one of, it's not the only central public repository or anything like that. It is very, very popular. And it's popular as a repository for a bunch of different reasons, but it also has kind of a social element to it. So a lot of people who get involved in working on software projects can go and find a project that they can just work on, right? That they, as long as you have some of the skills, and you don't have to be an expert necessarily for all these projects, you can contribute to those. In fact, I would suggest look around on here, because not all of these are sort of very high-tech kinds of things. There's a whole set of, almost 4,000 repositories that are lists of awesome stuff. So if you know what stuff is awesome, you can actually go to one of these awesome lists about all kinds of topics. I don't know what this one is, but you can kind of look here and see what the project is, and cybersecurity, GDPR. So it's kind of a list of things that are awesome, or there's a whole bunch of these, obviously. There's 3,000 odd of them. And you may actually know something awesome that you can kind of suggest as part of this process. So you'll get a feeling for how to work on these without messing up any code. Not that you would necessarily mess up code anyway, but you can kind of get a feeling for how you pull the data down, how you kind of clone the repository, how you decide to request that get pulled back into the main branch. All right, so as a practical matter, what do we do with all of this? Well, let's go ahead, and this is a bit of a chicken and an egg problem. Normally, I would create a new kind of Git project on my own machine first, using Git init, but our focus here on GitHub is probably well served. So let's go ahead. We're not going to find a repository. We're going to start our new one. We're going to have a repository name, and I'm going to call it, be really creative here and call it STC510. Note that I can call it STC510 and you can too. This is STC510 that's related just to me. So it has to be unique to in my space. But as long as you have your own space, you can have your own STC510 space as well. And I'll just call it a space for data. So you actually, I shrugged some of this off when we were doing the API stuff, but since all of this is going to be public facing, you probably should tend towards the more descriptive. This is meant to make all of this easier. And if you are just if you just put in here a new repository or something like that, you won't really be very helpful to those who kind of encounter it or want to use it. So that's worthwhile. You almost always want to have a README file, so we'll let it make it for us. I'll go ahead and do a git ignore without a template. So we'll just have it make that file, and we'll talk a little bit about what that is. If you know that you're doing a project, for example, in Python, you might want to choose the Python one. Well, we'll go ahead and do that. We'll grab the Python one. And we'll talk in a second about what that actually means. And we could choose a license. Why not? I'm a big fan of some kind of a license. Let's do a Creative Commons 0 universal. There we go. And then we're going to go ahead and create that repository. And it's going to think. And so now we have a new repo, a new repository on GitHub that we can use. And we have these 3 files that we asked for it to create for us. We can take a look at the README, and it says just our little description there. We could actually edit this directly on GitHub. This isn't the best way to do it, but using this to show how to use Git, among other things. I'm going to ask you to be using Git to submit things going forward. So, it's not just for this one little section. We'll kind of, as we go for the badges going forward, I'll ask for your files in GitHub. So, and let's go, we can preview those changes. That looks good to me. That little green bar shows what's changed. And I can go ahead and I can commit directly to the main branch. That is, I'm making a change directly to that main branch. Don't worry about this too much for now. I'm going to go ahead and kind of just, for the purposes of this section, we're going to be working exclusively with the main branch. So I'll go ahead and commit it. All right, now I can go back to the main project, and you'll see that this was, we have an initial commit for each of these, which means they've been created at that time 1 minute ago. And now we have a new updated version of it as of now. All right, so we've got this on the site. What if we want to, the standard process here is if I was going to work with this on my own computer here, this one's out there at the repository. If I'm going to work with it on this computer here, I need to be able to clone that repository, basically get a copy of that repository locally so that I can work on it as well. So there's a few ways we could do that. It's a little bit tricky because I'm going to go to the command line because even if the command line isn't your most comfortable, is the most comfortable space for you to be working, it's good to be able to kind of, it's actually quite easy for the things we're doing for now. And although I would normally just say, let's just use the GUI, let's just use the pretty application to do it, I do think that for these basics, it's really important that you get a feel for how to do this at the command line. Now, it's a little bit tricky. It's easy if you're working on a Linux machine, just drop to your shell. You can do that. And it's also pretty easy if you're working on a Mac because you can drop to your terminal. But we've been making the choice here with the assumption that many of you will be working on a Windows machine to be playing with Windows. Now, we have a couple of shells. We have the basic Windows shell, which you get by doing, command, and you get to the Windows shell. We have a shell because we installed Anaconda. We have a shell here that's the Anaconda PowerShell or the Anaconda regular shell, where we can open that up. If you go to your start menu, if you installed Anaconda in the earlier section, you'll have this Anaconda PowerShell. And this is kind of like a Windows shell, but with Anaconda kind of attached. So it's a little tricky, but it kind of gets us there. And if you want to use that shell, and there's some reasons you might want to, you'll need to install Git. And I put the command here for what you want to do using Conda to go ahead and install Git to your Anaconda's prompt. And then from there, you'll be able to use this prompt. I can probably put this, this is just a single line of code, conda install -c anaconda git. It's pretty straightforward. I'm not going to hit enter because this is already installed on my machine, so it won't look like it does when you do yours. But this is one option. We've made things more complicated because we've also done that the file system install of bash. And so with that, Git is included in the bash. So there are advantages and disadvantages to this, but I'm going to go ahead and keep moving with this. This is the one we were looking at before. We have data there. We can do a quick look and see what's in there. Those are the things we'd worked on before. We don't really need that anymore, so I'm going to rm data. I'm not actually going to do that, but you'll see why. Can't remove it because it's a directory, but I can say rm r data, and it will get rid of it all. And now if I do an ls, it's just the datafication lab. I'm going to leave that there for now. We may use it later. So I don't need to clear that, do I? No. So I'm going to do some things now to try to get a repository here. First, let's make sure we have Git. So we can do that by doing git -- version. And it doesn't, depending on when you see this video, you may actually have a newer or a slightly older version of Git as long as it's not way out of date. So for example, if you're running this on your Mac and you bought your Mac in 1992, you may need to kind of update your version of Git. But pretty much, if it's somewhere in that range, you're probably in good shape. So let's go ahead and get that repository, and let's go back real quick to look at the repository. If I want to clone this, what I'm going to do is I'm going to look at the code here, and it has an HTTP version. There's another way to do this by setting up SSH, but we won't worry about that for now. There's an HTTP version where it gives us a URL that will help us to do this. So I'm just going to hit that to copy it. And then I'm going to come back here and I'm going to say git clone, and then I'll do that, paste in that URL that I just grabbed. And it's okay. So it's not, because I'm already logged in, it's not going to ask for my login information. But in your case, it may actually say what's your username on GitHub, which is going to be something like your usually your email address, and then it's going to ask for your password on GitHub. It didn't do that because I'm already logged in, and so it knew that. But you can see it's telling us what it's doing. It's found some objects. That's actually more objects than we would have expected, but there's some hidden objects there. It's counting them, it's compressing them, it's sending them, it's unpacking them. Now if I do an ls, you'll see that I have a new directory here, stc510. And so I'm going to cd into that. And I'll do a quick listing of what's in here. And I've got the license and I've got the README. You'll note that I'm missing one of the files that I had over here. If I look at this one, there's actually 3 there. There's a .gitignore and those other 2. Sorry, let me leave that there for a sec so you can see. So we've got a license, a README, but we also have this .gitignore, which seems to be missing. It's not really missing. When you have a dot in front of it, it just hides it so that you don't see it. We can make it show all of them with -a, and then we can see that there's actually a gitignore and a .git. In here, there's a bunch of files that help Git work. And so we don't really need to worry. We don't ever have to touch that. We can look at it if we want to. You probably shouldn't change anything in there. But this is kind of where its database is, where it keeps track of all the changes we're making. This one we'll talk about at the very end. The license is just something that's a license. And then the README, we can... capitals matter. And we just did this, remember, the space for the data wrangling course, use this to show how to use Git, among other things. Now, what if we wanted to add some files to this? Again, this is Windows specific, but there is now a way. For a while, the Linux subsystem that was on Windows couldn't really talk to the rest of the file system, so there wasn't really a way to cross over that boundary. Even though it wasn't a virtual machine, it was kind of, well, it is kind of. It wasn't sharing the same file space. There is now, and that is, so I'll show you real quick. I can launch the Explorer from here, and I'm going to launch it with that dot. That dot means in this directory I'm in right now is where I want to launch it. And so if I do that, it'll pop up an Explorer window in Windows, and you can see I can see the files that I just talked about here in Windows. And so if I wanted to drag some files in here, I could potentially do that. There are some potential issues around that, but I think it would be pretty straightforward. So I'm going to keep working though right in here. Since if this were the first time you were using Git, there are some things that you need to kind of take care of getting not installed, but getting set up as a configuration. And so we'll do a git config, config. And the first of these is we need to set our username globally, user.name, and because this is my actual human name, and because it has a space in it, I'm putting quotation marks around it, Halave. So that sets the fact that I can't spell. I wasn't trying for config, but config. So that sets my name. Similarly, I'm just saving some typing there by doing user email. And what these are used for is when you do a commit, that is when you make a change to a file and you record it, it's going to kind of see who made those changes. So you need to make sure that these are accurate so that people know who's changing what. And so we'll go do that one. And the last of these is where it gets especially tricky, because I'm on a Linux machine, but on a Microsoft machine, and so I'm actually not entirely sure how this is going to wash out. But we've kind of run into this without talking about it. But one of the differences between Windows and other file systems is how they handle the new lines. So the CRLF is carriage return line feed. So some computing systems, in fact, you really don't care about this, but my very first consulting job was dealing with this question of a carriage return versus a carriage return and a line feed. So in some of the things that we saw in earlier versions of this, you saw the \Rs and \R/\Ns. They handle them slightly differently. So if you are on a Linux machine or a Mac, you can kind of put this as input, and that should work. If you're on a Windows machine, this should be true. And because I am kind of on a Linux machine, I'm going to assume that the Linux subsystem is treating the files like Linux. In other words, that's how it's handling. It's putting in just the new line and not both. So I'm going to set this as input. If you went back and you were using the version that was kind of Anaconda within a PowerShell or within the regular Windows shell, you'd want to set this to true. This seems like it's in the weeds. The problem here is, like, if you make a change to a file and it adds a whole bunch of extra carriage returns into it, if it makes extra spaces in there where they don't belong, it's going to be very frustrating for everyone. And so you try to make sure you make up for Windows being the odd person out by setting that configuration. All right, now that we've got it all configured, we can take a look at the status real quick. And so this says I'm up to date with the main branch on there, and I haven't done anything new here. So basically we match up. But let's go ahead and create a Python program. Let's create hello.py. Generally, Python programs end in .py. So far we've had the longer version because we've been looking at Python within notebooks, right? But this is just going to be a pure Python program, and I'm going to use the Nano program that I talked about a little earlier, an editor that's kind of built in here. And this is going to be a new blank screen. And I'm going to do my favorite one-line program. Right, and there's my Python program. Pretty straightforward. I could make it fancier, but that works for me. Now, if you look down here, it says to exit, I need to hit Control X, and then it's going to ask to save this buffer. That means, did you really mean to make these changes? And the answer is yes, so I just hit Y. And it asks what file to write, and since I had it at the beginning, it's guessing that it's hello.py, and it's right, so I hit Enter. Now, if I do a quick ls, you'll see that I have 3 visible files here, including hello.py. And if I do a quick cat hello.py, I can read that. There's my program, and I can actually run my program if I want. Python 3 hello.py. Hey, hello world, it works. Okay, but now if I do I'm not sure what will happen here. We can do a quick git status, and it says we have an untracked file. And it's not sure whether we want this to be part of our changes to this whole project or not. And so we need to pretty explicitly say, yes, please add add hello.py. So what we're saying is, please track on this file and the changes that get made to it. Now, we know it's new, but please start tracking on it because we want it to be part of the project. Now again, I'll do git status, and it'll say, okay, we have something that's a staged file. What that means is we've kind of moved it forward, and we say, this is part of what we're working on and part of what we want to be part of the new collection that we have. It's sitting there, it's in green, it's ready to go, but we haven't actually saved it in as kind of a commit. So when we hit commit, it's like taking a snapshot of the project, and we're like, okay, it's kind of this is a place we might want to come back to, right? We're kind of happy with the project. How often do you do that? Well, if you're working on it for an hour or two, you might want to just kind of, you don't want to do it every time you change a line of something or every time you touch a new file. But if you've made some progress and it seems like it's working, that might be a good time to actually do a commit. And so to do a commit, we just do, this is going to be really surprising, git commit. We're going to add the message here because it's easier. Every time you do a commit, you can just say what it is that you've done to this, because as a human, you need to know, as someone else working on the project, you need to know, okay, this person has committed a change to this project. What the heck did they do? I don't want to have to go and read through all the differences between the old code and the new code. What is it that they were trying to do? And I could just say, something like that, right? And so what it says is that it kind of tells us that it's done this. It's one file has changed, and there are 2 insertions, and it's created this. Now, that means that I have a, it's taken a snapshot of this. I can keep working on it a bit more. I can do some more saves, but if I ever have to back up to this, there's a snapshot there with what's called a hash, a function that says what exact, a unique identifier for this one time of this project in this one place. Now I say in this one place because it's still just sitting right here. I could have been disconnected from the internet the whole time I was working on it. After I cloned it, I could just be sitting here on an airplane working on it, right? But I've done these commits. Now I want to kind of let the central repository know that these have happened. So now I'm going to do a push. And what this is going to do is now it's going to ask me for my username. And I'm going to have to see if I can remember my password. And I've messed it up. I doubt that. Oh, it did. Yay, I got it. Okay, I'm thrilled. So it's telling us a lot about what it's doing. It's going and kind of checking care of things and moving them up there. If I now go back to GitHub, you'll see that, in this main repository, I can do a quick refresh, and you'll see that we now have this program here. 2 minutes ago, it was committed, right? And we can click on it, and we can see here's the change that's happened. This says that, well, obviously the change has been from 0 to a new line right here. And so it tells us that's what has changed in the file. Okay, and here's the commit where it says 2 minutes ago. Here's that hash I was talking about, the unique identifier. So we get a feeling for what has happened here. Cool. So for now, that's basically what you would do. And then if you came back to this sometime in the future, not right now because we just committed it, but I could then do a git pull, and this would pull down, well, I'm already up to date. So, but it would check and make sure if there were any changes, it would pull them down so I could then work on the freshest version of it, right? That process of working on it, doing the commit, pushing it back up, pulling it back down, that's like, we've hit maybe like 3 commands there, right? Git add, git commit, push, pull, we've cloned as well. So 5, those are probably the 5 most frequently used commands. And there's maybe 5 or 8 more that you might use on a consistent basis if you were dealing with a larger project. But just knowing those 5 get you enough that you can kind of bring things down, put them back up, and contribute to projects in various ways. You do need to know a little bit about forking, but that's something that until you're ready to work on a larger project is probably unnecessary at this very initial stage. There is one more thing that you probably should know, which I said we would talk about, and I don't want to ignore entirely. ls, and we'll list all of the things. So I told you about this file right here, git ignore. Even though you're working on this, there are some things that you probably shouldn't be making part of the repository. So I'm opening this up in an editor just so you can see some of it. But what this says is which parts of this directory you should ignore. Now, right now, we don't actually have a PyCache. We don't have any .so files. We don't have a .python or a build or develop eggs, because these are assuming that we have this huge Python project here where we've been compiling stuff and where it's been doing bytecode and where we have all this stuff, right? And we don't have this right now, but you don't necessarily want anything but source code going up and down. This is the caveat that will cause you to have to think way back to module 1 again, which probably feels a very long time ago. But at the very end there, where we were dealing with the API, I mentioned that you have to be careful about your API keys and things like that. Normally, you would put those in a separate file, and then you would add that file to this .ignore setup. You don't want to be adding things that are private passwords to a repository. And you'll find that for a lot of software projects, like if you ever install a Django project, or you ever install even like something like WordPress, you'll see that a lot of those setup files are put in a separate file for that reason, so that you can keep those outside of your backups and your archives, so that people can't easily find your passwords. I think that's it for now. I know that's a lot. Hopefully, I tried to do this at a very lightweight level, and so hopefully you've kind of gotten this process. You won't see the value in it until either you're involved in a project with multiple people, or you make a huge mistake in your work and you have to back up. And then you will see why this becomes a pattern for people, why when they work on stuff, they work on it this way. A lot of the things that we've done today in this process, you can do using a graphical interface if you like. I will tell you, in this case, I don't think it's idiosyncratic for me. I think this process still just works better in a console, at the command line. But there are people who swear by some of the newer tools, especially people who are using it every day and using it a lot. So I don't want to poo-poo that as a possibility. And so you're welcome to explore those. The actual things that you do on those are going to be the same things we did here. So you're still going to be doing adds, commits, pulls, pushes, cloning, right? So all the same kinds of things we've just done with commands, you would be doing with the GUI by clicking a button that says, commit or something like that. Okay. All right. Well, thank you very much.